If I was working on an extremely large production which required bringing in more sources and possibly different approaches to what I wanted to use the master faders for, then I need to configure layers, console layers. This allows me to switch effectively the focus of the physical channel strip from one piece of processing to another piece of processing. There are no fixed layers or layouts on a C10 because without knowing what the production requirements, it's not effective just to waste switches on layer switching that might not be required. So when you want to use layers, you have to assign either dedicated function keys, or we can assign the user-assigned on-screen functions to layer control. At the moment, I've got 3 buttons assigned to switch to different layers. So here we've got layer 1, layer 2 and layer 3. I've left them as layer 1, layer 2, layer 3. However, there's nothing to stop you relabeling those functions as sort of presenters and then music, and they can be user relabeled, for example. If I switch to layer 2, then basically I bring up a complete new set of channel strips. Looking up here, we look at strip 16. Currently, it's assigned to channel 16. So underneath the main channel strip label is actually the DSP channel, or the actual console channel that strip 16 is assigned to. When I switch to layer 2, then it's actually assigned to channel 48, which is a mono channel connected to track 12 from a playback device. So this is just like bringing up a new set of channels straight onto the surface. And again, in exactly the same way, in this layer, I've got all 8 audio subgroups assigned to the master faders. If we want to reconfigure any of the layers, then we use the Edit Layer menu. Within the Edit Layer menu, we have a number of options available to us. First of all, Edit is where we actually configure the layers. And that brings up one of our menus controlled by the stepped encoder, the scroller in the center section. And we use the attention keys, for example, to select the faders that I want to change what they're assigned to. And then here I have a list of functions. I've got master faders, channels, master faders, audio subgroups, program, even my aux bus and mix minus bus outputs. And if you have the option, I can even assign these faders to controlling an external workstation, for example. I'll go back and I'll select, I'll select from. So here I've brought up actually some channels that are in the previous layer, but that's perfectly allowable. There's nothing to stop you repeating channels in multiple layers. So it's possible to keep this bay essentially fixed while these bays bring up different groups of signals. So for example, here I've brought back signals that actually were in layer 1. However, I've brought them back in a slightly different order. And that brings us to another aspect of what we can do with the surface, which is to move strips. So for example, if I decide that the 5.1 return that I have, I'd like to bring that closer to the center section. Okay, I select the move function. Then I go back and attention the channel, which this time is outlined in red because this is not, we're not assigning it to the center section. We're going to do something different with it. And then I use our stepped encoder or the left-right keys to position that channel where I actually want to place it. So I've scrolled it to that point and now punch down on the encoder, drops that channel strip on that fader strip. So now it's still called fader strip 16, but it's now assigned to channel 13. So I can do this with single channels, or I can take groups of channels if I wish, and move those. So at any time one can optimize the surface layout to suit the operational requirements. You can bring signals that you really want under your hands all the time, to, regardless of how you first put them into the layer. Center section functions the same. If I decided, for example, let's say I wanted to have the aux send masters, then again you go edit. So I select an array by selecting the attention keys on the first and last of the faders. Select, and then scroll down to my aux buses, and now I've got my aux master faders on here. I can AFL an aux output, for example, and that is reflected on screen. But when I mute it, you can see that the faders are greyed out to show that the faders are up, but the aux output has been muted. The C10 was designed to be used by a variety of skill sets, and to that end we've created access levels for the users. Depending on your skill set, the operators are assigned passwords for the various access levels. The on-screen padlock brings up the access area. There are 4 what we call access levels or operational modes. Administrator is access all areas. This is for the chief engineer, a technician, a very experienced audio operator. It allows access not just to the main setup functions, but also to the service menus and the diagnostics routines, and for basic I/O setup functions and network setup functions. Normally, we use the standard operational mode. This is for, again, an experienced operator, but locked out of menus that could change basic system configuration. So when we go into our menu system, we still have access to all the primary touchscreen menus. However, when we select Studio, we're locked out, and a warning bar is displayed saying Control Disabled. That has locked us out of all setup menus. I need to be the administrator to have access to the Studio menus. For example, just to demonstrate that, I'm now going to log in as administrator. And this time when I go back to our main menu and I hit Studio, then I go to the setup control page and I get access to all the basic system configuration and setup menus, including the ability to restart the console system should I need to do that. All right, this time we're going to go in as a preset user. This is for the less experienced engineer. He's allowed full access to the basic channel strip routing and level control functions. I'm allowed access to the faders. I've got full access to the encoders. I can route my signals to the program buses, set up mix minuses. However, when I go, I would like to EQ something, that is not a function that's available to me. I can't, in fact, even go into the next level of menus down there. I'm locked out from the center section operational menus. I would have loaded a project from our dedicated project keys. I'm allowed access to presets so that I can look up who is the newsreader and load his settings, but I'm not allowed to modify those settings. So I go with preset EQ settings. If I wanted a program limiter, then I would load a program limiter setting or a program limiter preset that a more competent engineer had already set up. This is what's called the preset mode. This is for the novice user or someone who is just a general purpose broadcast engineer who has to do some simple audio functions on the console. The locked mode is for unattended operation. For example, if the console was being used with a news production automation, enabling locked now means that nothing on the front panel is in circuit. So it is impossible to disrupt what the remote control from the news production system is doing to the audio. Or, for example, you just needed to leave audio running through the console and walk away and leave the console unattended. The monitoring is functional, so it is still possible to listen and dim and mute the monitors, but only level, dim and cut are available. Every other control is locked out. And to regain control, you have to log in at one of the other levels. So that is the access level control, which sets the operational modes for the front panel. In addition to the channel preset system and the control linking, we also have a full snapshot system for resetting the entire console. This is controlled from the snapshot manager, where you can store a list of console snapshots. You can reorder the list. You can incrementally fire snapshots in the list. You have a simple replace for editing snapshots, duplicate for repeating snapshots. There is, of course, an undo key, so that, for example, if you fire a snapshot, you can undo and return to where the console was prior to firing that snapshot. We have a 5.1 channel here. Sometimes it's necessary to EQ or even send to the aux buses at different levels from the various components of a 5.1 channel. So one of the functions that we can do with the C10 is to spill a 5.1 channel or even a stereo channel into its component mono channel paths. We do that by attentioning the channel, and then to spill it, we either use the on-screen spill key from the parameter menu, or I have a programmed spill key in my function keys, and then the channel is spilt out onto the adjacent faders, and it becomes like a group. Here is the 5.1 master fader, and here are the individual components. So it's left, right, center, sub, left surround, right surround. So if I need to EQ, for example, the center signal independently, then I can select the center and apply EQ as required, just to the center signal. Or if I select the master, I can apply EQ to all the components except the LFE channel, which is always excluded from EQ functions. If we wanted to change the balance of the 5.1 channel to ascend, for example, reduce the surround component, we would select the send using the function select keys. On the master, you can see all the individual send levels track, and then I go in and I adjust the individual send levels as before. Hit the spill key and the channels that were there are brought back to the surface. We've also implemented spill with the VCA grouping system. This gives us an alternative way of managing a large number of channels on a smaller surface. By assigning channels to the master fader and having those channels effectively on layers underneath, we can be in our main layer and we can spill a VCA fader and instantly bring all the channels controlled by that VCA fader to the surface. We can then change the balance and then return to the previous channels. Or we could just use it for example, in a sort of mixed media type show where you were dealing with speech segments and music segments. This would be the band, and then if you wanted to change the band balance, you just bring the band to the surface. When you're happy with the balance, return it, and then you go balance, then you've got the band presenters. So it's another way of managing high channel counts on a small surface. Another example of using this system would be for crowd mics in a large arena. The crowd mics could just be on a single fader, and then if you needed to change the balance, you bring them to the surface, change the balance, and then hide them back under the main channels. When we spill a VCA master, we're not just bringing the faders to the surface, we're bringing the complete strip to the surface. As you can see we get a completely different set of iconics images. So what we're doing is we're bringing up channels that were on a separate layer into the current layer. So we have full access to EQ, dynamics, full control over the routing. One of the most vulnerable areas of a digital console is its control surface, because the control surface contains parts that may fail or may get damaged. We have moving faders, we have switches, we have rotary encoders. All these could be controlling a key element in our broadcast. If one of these components was to fail on air, we have to find a way of working around this failure without having to do complex operations like reroute signal paths, copy settings from one channel strip to another channel strip. So we've included a very simple method of moving channels on one bay to another bay. This allows you to carry on effectively with a reduced size control surface until a point can be found where you can rectify the fault. This menu is found in the MISC menu and it's called Surface. And it pulls up a display of the console. Supposing this fader fails, and this is my announcer, I need to find a way to work around that very quickly. I touch the on-screen representation of that bay, and then I disable the channel strips, and all the channels on that bay have been transferred to this bay, and I can carry on with the broadcast. And what has happened now is we've created what I would term a scrolling surface. On the surface now I have strips 1 to 24, and the last 8 strips are virtual strips, and we can shift the surface between 1 to 24 and 9 to 32. So we use our 2 left-right scroller keys to literally slide the surface, omitting this bay in its entirety. So if I needed to get to something on 32, then I scroll. Here is bay 32. I need to get back. I'm back here. It means that it took a few seconds to carry out that operation, and it allows someone to work around a failure on a physical strip very quickly. When normal service is restored, then you just re-enable the channel strips on that bay. If there was a failure on one of the master faders, we can do the same thing. We can transfer the functions on the master faders to one of the other bays, in which case everything shuffles up one, and these now become my master faders, and those faders have been disabled. And again, we scroll to the last to channel strips 25 to 32. A very powerful feature that allows you to overcome a physical problem with the control surface. One of the options that we offer for C10 for very critical applications is full processor and control redundancy. This basically means that the system is fitted with a mirroring processing engine, complete with its own hard disk RAID array and server. So we effectively have 2 complete systems running side by side. And at any time, using the 5th user mode key, we can switch over to our backup system. The status of the system is indicated at the top of the touch screen. If you have the redundancy option fitted, you will see a display. What is actually happening is that the 2 systems are synchronizing continuously. Every time I move a control on the surface, that change is communicated to the slave processor. And for a moment, the tick disappears, sync busy is displayed, and when the tick is restored, the slave processor has been updated. So this means that at all times, the slave processor is mirroring that of the master. The I/O is connected to both engines, and it's the I/O that switches between the active engine, be it the master engine or the slave engine. In the event of an audible problem or a control problem on the master, then to switch over to the slave, we need to push and hold the reserve system key in the user modes. At that point, the audio changes over virtually instantaneously, and then the control surface takes about 10 to 15 seconds before it reconnects to the slave processor. Just to show you what happens, let's initiate the changeover. So the changeover is now happening. There may have been a tiny little interruption in the audio. However, I'm now locked out of the surface. And then as soon as the screens have redrawn, I regain control of the surface. And now you can see, for example, that we now say slave, but we still have the tick that's saying sync OK. So we're now running on the slave processor, and we can carry on until we have a chance to investigate whatever problems have occurred and rectify them. As soon as that happens, we can then return to the master processor, and we can repeat the process to go back. So audio is virtually instantaneously control takes 10 to 15 seconds before you can then access the main processor from the control surface again. A very simple but effective way to have a fully redundant system.